So, who wants to ask first? For chapter 12, do you have any problem that you want us to talk about? Is all clear?
Yes, doctor.
Okay. 13.
دكتور أنا بتشابتر 13 ما
Okay.
فهمت كيف عم
يلا.
نجيب angles.
Okay. So you have a specific problem. You mean cylindrical بالcylindrical
يعني
coordinates?
yes. بعتقد 13 exercise 13.
13. Yeah, let us do it together. Okay. Yeah. Okay. So determine the normal and frictional driving forces that the partial spiral track exerts on the motor of mass m at the instant theta and function of theta prime theta second. Neglect the size of the motor. Okay. Let us look at our figure. They gave us information about the angle. And for this angle, what is the angular velocity and what is the angular acceleration? And we want to find the normal and frictional driving forces acting on the motor. So first, let us draw the free body diagram of forces. We have the weight. We have the normal reaction. And since they said normal reaction is tangent, is perpendicular to contact. And the contact line here is what? It's the tangent line. Okay? So if you draw the tangent to the path, your normal reaction will be perpendicular to this tangent line. So this is N. And your frictional driving force, because it's a driving force, so it's along the direction of motion, it's downward. Okay? So you have F is down. And you want to calculate these two forces. You have two unknowns, F and N. Okay? Now, maybe you can say, let me use first, because F and N are along UNUT, why I don't use UNUT components? Because I don't have an idea about the radius of curvature. Okay? Here, they didn't give me the motion as y function of x to get the radius of curvature at any position I want. If I have the equation of this line as y function of x, then I use normal tangential coordinates because I know that an is v squared over rho and I can get rho. But here, no. They gave me the path of motion in cylindrical coordinates. They told me that I can identify the position of my motor at any angle theta by giving r as a function of theta. So they told me that r is equal to b, which is 5 times theta. So since I have r expressed function of theta, I will work in in cylindrical coordinates. And in cylindrical coordinates, I should draw the figure in a better way. N is perpendicular to the tangent line. So it's, if you want to have a small difference, it's like this. So if I draw the tangent accurately and I draw N, it's perpendicular to the tangent line. So it's not along UR. It can be for certain particular position along UR, but not here. Okay, so in general, the tangent line will do a certain angle with UR. Okay, so this is your, if I draw it here.
دكتور بس كيف عرفنا عن هي
كيف عرفنا انه شو؟ Can you repeat?
إنه هي منا along you are
ما فينا نعرف. اوكي بس انت you cannot rely on the figure. You don't know if this theta is really 5 pi over 3 accurately. Okay, يعني if you draw the tangent line you can draw it approximately, but can you be sure that your line is 100% right? Plus you don't know if this angle theta presented here it's actually 5 pi over 3. You don't know, so you can consider any possible location and draw your diagram. In general, at any location, okay, the the normal is perpendicular to the tangent line, but the tangent line doesn't have to do an angle of 90 with UR. And if you look at UR, this is UR. Is this angle equal to 90? I cannot judge, okay? If the angle is equal to 90, it's great. This means that the normal is along UR, but I cannot be sure of this. I cannot be sure of this, okay? So that's why I need to go through calculation. It might be at this position, if the position is accurately presented here, it might be close to 90, but it can be little. If you have a little bit difference, then you need to take into consideration this. You need to find if I put UR, this is UR. This is my UR vector. And I have a way to calculate the angle from UR to the tangent line along theta positive. This is the theta positive direction. This is psi. I have the option of calculating psi. If I get by calculation psi 90, it's great. This means that UR is perpendicular to the tangent line and the normal will be exactly along UR. But what if there is a small difference? If psi is a little bit smaller or larger than 90, then if I calculate my angle between the normal and UR, it will not be zero. Okay? So I need to do calculation. And I know from calculations that what is psi? Psi is equal to 10 minus 1.
It's R over the R.
Exactly. Of R over dr by d theta. Let me apply it here. Okay. R is 5 theta. And dr by d theta is 5. So if I simplify, I get that psi is 10 minus 1 of theta. And what do with your calculator? 10 minus 1 of 5 pi over 3. What do you get?
Doctor, so we always, when we're working with pi, we put our calculator to be on in region, صحيح؟ ما نشتغلها بالديجري.
Yes, of course.
Okay.
Yes, so when you put look, when you put 5 pi over 3 فيك تحط 10 minus 1 5 pi over 3. You can put your calculator in degrees. It will give you then the angle in degrees. It will give you psi in degrees. Okay? But when you replace,
yes.
5 pi over 3 is a number. Pi is always 3.14. You don't put 10 minus 1. Even if you have your calculator in degree mode, you don't put 5 times 180 over 3. Tan theta, tan psi is 5 pi over 3, where pi is replaced in radian. But if you put your calculator in degree mode, tan minus 1 will give you the angle in degree. If you put it in radian mode, it will give you the angle in radian. Okay?
Okay, thank you. Yeah.
Okay, what is the angle if you do 10 minus 1, 5 pi over 3?
79.19.
Okay, great. So it's not 90. Okay? So it's close to 90 as expected. And if the figure is, you cannot know if the angle is accurately presented in the figure. Plus, you cannot draw 100% the tangent direction. So you cannot rely on drawing with your hand. You need to calculate. And now, once you calculate your angle, you can easily do your projections. Because now, you can say the following. I know that the frictional, the driving force is along the tangent line. And I know that the normal force is perpendicular to the tangent line. And this is my tangent line. And this tangent line is doing with my UR. This is my UR. I know that it's doing with my UR an angle of 79 degrees. Okay? Point something. I will take it 79. So now the angle between my UR and my normal force is 90 minus 79. It's 11. So when I want to project my normal force, it will have a negative projection along UR. So minus Fn cosine 11. And it will have a positive projection along U theta. So plus Fn sine 11. Okay? This is the whole idea. And I can do this for, I will do the projections also for the driving force. So here, they considered the driving force up, but actually, it's downward, because if they said driving force, it means it's in the direction of motion, unless my moto is going up. So let us check. The moto is going
Hey,
up.
doctor, I think it's going
Yeah,
up.
the moto is going up. Because the moto is going up, then the driving force should point upward. Okay, because they said it's driving. So this is why they considered F upward. Okay, and then when I want to project F on UR, it's a positive projection. I multiply by cosine psi. When I want to project it on U theta also, it's positive. I multiply by sine psi. Okay, and then I am ready. I have everything. I can calculate AR A theta from chapter 12. The only unknowns are my F and Fn. Of course, I need to project the weight also. But for the weight, okay, what about the weight? If you look at your figure, the weight is along this direction. Okay, and this is your UR. And this is your U theta up. Okay, please pay attention. What is theta in this problem? Theta is this whole angle. This whole angle. So this angle here, okay, is equal to what? To 2 theta, to theta minus 270. Okay. So now, when I project W on UR, I do plus mg cosine of theta minus 270 which is equal to minus sine theta. I can replace this by minus sine theta. Okay. And if I want to project on U theta, it's minus mg sine theta minus 270. And sine theta minus 270 is equal to cosine theta. So I can replace this by cosine theta. Okay. So in this way, I will have the projections of my weight. And now I replace sum of R equals MAR, sum of theta equals MA theta. I have everything. I get my two unknowns, two equations, two unknowns. Okay. Other questions?
Okay, doctor, thank you.
Welcome.
دكتور
Yes.
دكتور
Yes.
بس بالاكسرسايز 7 and 8 ما عرفت كيف اجيب الرو.
Yeah. Seven and eight. Okay, great. Okay. First, you should look at your figure, okay, and try to detect what is the circle of rotation. This is your circle of rotation, okay? This is your circle. So the radius, and in case of circular motion, rho is equal to the radius of the circle. So you need to get the distance from the axis of rotation to your particle. Now, it's not given directly here. They gave you the following. They told you, okay, you have this. Look at your figure. You have this distance. So if you divide your radius into two parts, you need to add this distance. This distance is d, equal to this one provided, which is 4 meters, okay, plus this part. How to calculate this part? You have here an angle of 90 degrees, and you have the length of your cable is given. It's equal to 6. And the angle theta also is given 30 degrees. So what is this distance? From this point to this point, you have 6 sine 30. So the total radius will be 6 sine 30 plus d. Okay? That's it. Did you
Okay, thank
understand
you.
here how we got the radius?
Yes, thank you.
Okay.
وفيني افكت ايه بليز بال8 كمان
Yeah.
دي في
بال8 same concept. First, try to draw the circle of motion. This is the circle of motion of your block here. Okay? So you need to determine, this is your radius, this distance. Okay? If you look at your figure, what do you know? You have a cone. And for this cone, you know that the radius at the base is A. Okay? And you know that this height is B. So you can say the following. I want this distance. This is my radius. So you just have to do some geometrical calculation. Since you know A and B, you can get the angle here, theta. You can say that tan theta is equal to A over B. Okay, so theta is tan minus 1 of A over B. You get theta. Once you get theta, you say, in this small triangle here, I know C. I know that C is 0.2 meters. Okay, so how you can find the radius in this triangle here? You can say that if I do R over C, what do I get? Sine theta.
يعني مثل فوق.
So what is the radius? So the radius is C
0.2 sine theta.
times sine theta. Okay. That's it.
Okay, deal. Thank you.
Welcome. Other question?
Yes, doctor. In number
Yes.
12, I didn't really get the
Okay.
motto of the exercise, and in the geometry side, I didn't really get it.
12.
دكتور نحن ما فايز نعمل geometry يعني
No,
إنه
you
بيكون
might
هيك
need, yes, you might need to do some geometrical analysis in case you have a relation missed. You might need to use, if you have a radius that is unknown, you can use geometry, of course. But no basic things, yeah, not complex things. Cosine, sine law, or if I have right triangles, sine theta, how to get sine theta, cosine theta, and these ideas, not more than this. Okay. If you look in the following problem, Chris, what did you tell me? What was the issue?
Like just a geometry makes why did we apply the sine law?
Okay, because in this problem, what do we have? If you look at your figure, you have first R, okay, that can be expressed here as a function of theta. That's why we need to use cylindrical coordinates. Okay. So first, what is R? R is the distance between the origin. So this is R, the distance between the origin and the particle. Okay, this is R. And the angle theta is the angle it's doing with the horizontal. So this is theta. Okay. And you know that if they didn't give me directly the relation here, they didn't give me R function of theta, I should find it. I should find it. To be able to find it, if I look at my figure, okay, I know that this distance from the center of this circle, so this is the center of this circle, okay? So I can, they gave me the radius, so from this point to this one, the distance is B, okay? So also, because it's also a radius here, so this is also B, okay? This is B. And this is A. Here, why the problem is really much more simple? Because A is equal to B, but then I solved it as if A and B are different. I will do both for you. If A and B are equal, this will simplify the analysis a lot. Because if A and B are equal, it's an isosceles triangle. So the angle here, this angle theta, is equal to this one. Okay? And then how you can calculate R? You can say that if I do the perpendicular here, okay, I can divide R into two parts. This one is A cosine theta, and also the other one is equal because I considered A equal to B, and then the angles are the same. So this is also A cosine theta. So if A equals to B, this will simplify things a lot. Then I can write that R is 2 times A times cosine theta, and then I continue my problem as usual. I find R dot, I put my free body diagram, I project my forces, so it's always same technique, okay? But what is more challenging, and here I did the general method, is if A and B are not equal. If A and B are not equal, so I have to take my triangle. I will draw it here on a bigger scale. Okay. Let us consider A and B to be different. So this is A, this is B, this is my R, and this is my theta. Okay. And this angle, if I have a general triangle, I can call this angle phi, and phi is different than theta. But to express what is R, also I do the perpendicular. And I say that R can be written as R equals A cosine theta plus B cosine phi. But the challenge is that I need to, if you want, I need to have derivative with respect to one variable. And already I have R function of theta, and theta is function of time. Now I introduce a new variable, which is phi. I need to relate actually phi and theta. Because if I relate them, instead of dealing now with R function of theta and phi, I will only deal with R function of theta. Okay, so I need to relate theta and phi. To relate them, I use the sine law. Okay, so I can say if I take this triangle, in this triangle I have A over sine phi okay, so A over sine phi equals to B over sine theta. Okay, So in this way, I can find, if I take sine theta to the upper side, you have A sine theta equal to B sine phi. So I related my angle. And now if I want to relate their derivatives, I can easily do this. So once I get this relation between the two, I can relate the derivatives of theta. I can relate theta dot and phi dot, and also the second derivative. And for example, when you calculate now R dot, what is R dot? R dot is A minus A sine theta theta dot. And similarly, for the second term, it's minus B sine phi dot. Okay. But I don't want, I have two variables, theta dot and phi dot. So I need to relate phi dot and theta dot. To do this, I derive this relation with respect to time. If I derive this relation with respect to time, what do I get? I get A cosine theta dot equals to B cosine phi dot. Okay. So now I have a relation between phi dot and theta dot. Okay. So just here, it's a little bit more complex because I introduce a new variable. So I need to find what is phi function of theta and what is phi dot function of theta and theta dot. Okay. Is it clearer?
Doctor, but even if the relation between phi dot and theta dot contains phi, so I will not be able to get rid of phi in this case.
بلا ما أنت already
Because it's cosine phi.
أنت you can get, look, if I give you a value of theta, think in this way. If I give you for a certain angle, you will do the calculation for a certain theta. Let's say I tell you for theta equals 30, what do? You replace theta by 30 here, you can calculate phi. And once you calculate phi, you replace it, okay? You already found phi function.
Yes, I got it. Yeah.
Okay. So then you will not have any more phi as
you need to give us a certain value.
Of course.
You need to give us certain value to get rid of the other. Okay.
Exactly.
Okay. So when I was doing the exercise, I did your first method, and it's correct. I can do that. Yes, it's 100% correct.
Yeah, of course you can, because A is equal to B.
Okay, thank you.
Other questions?
Doctor?
Yes. Can you repeat, please?
Yes. أيام في exercises they like combine the forces along X and forces along Y بذات الوقت.
Can you give me an example, please?
Yeah, 1 second بس أفتح الفايل.
In which fold?
Chapter 13.
13? Okay. 13 or 13 review problems?
Yes, تبع review
Okay,
problems.
which problem?
Review problems اللي
Okay,
نحن
but
فيه
which
already.
one? What is the number? Do you want me to scroll down over them?
ما يلا عم
Okay.
لا أنا عم بشوف عندي على الفايل أي واحد.
Okay.
Okay, بعتقد number 5.
This one, are you sure?
Yes.
How they are combining? Look, here's the friction. ما أنت, what is the friction force? How you calculate friction? Kinetic friction, it's mu k times n, صح?
مظبوط.
And n is in the vertical direction. So to get n, you use sum Fy equals 0. But you are not combining in the same equation x and y. And look, along y direction, x direction, what do you have? If you take this block as system, okay, if you consider block A, you have the spring force acting on it, you have the action of B on A, so this is the force of B on A, and you have the friction with the ground. So since you have slipping, you have kinetic friction. And how you find your kinetic friction? Your kinetic friction is mu k times what? Times the normal between the ground and the block. So mu k and A. So when you write your sum of forces in X, this is your sum of forces in X. You have minus this force, spring force, minus this reaction FB on A. هنا they called it N. يعني هيدي ال N is different than NA. Pay attention. This is N, which is F of B on A. It's different than the normal reaction from the ground. Okay? Minus mu K NA. What is NA?
هل N ما قصدهم فيها normal force؟
نعم. N is not the normal force with the ground. It's the normal force between
هيدي ال N اللي
along X. N here represent the force of block B on A. It's
okay,
the
okay,
normal
okay.
force to contact line here. Okay? While the normal is, they called it NA. And
Okay.
to get NA, you do sum of Y equals 0. You have NA equals the weight of A. Okay?
Okay.
Other question?
دكتور أنا كمان review problems exercise 11
Okay.
ما فهمت ليش بس سألونا إنه أي متى it doesn't slip شوف إنه كان بدنا إنه أي متى ال friction will exceed the static friction يعني ما
Okay.
فهمت إنه ليش هيك
Okay.
فكرنا.
Because what do we mean when they say slipping? Yani you have different velocities between the block and the belt. As long as the belt and the box are having same velocity, there is no slipping condition. And whenever you have non-slip condition, the friction between the two surfaces should be static. And what is the limit of static friction? Yani the static friction can increase until reaching its upper limit. What is its upper limit? Mu s m. So whenever they ask if you want to find the extreme condition to avoid slipping, you put F, the static friction, equal to mu Sn. You put it as at its maximum to get the extreme condition.
يعني once we exceed mu SN بنصير
بالkinetic,
movement
exactly. بصير في slipping between the box and the belt. They will not have any more the same linear velocity at the contact line.
Okay. Thank you.
Welcome. Any other question, guys? Okay. So I hope that we can
بس
meet.
دكتور
Yes?
دكتور
Yes,
في
yes.
سؤال
Tell me.
يعني احنا عنا يعني سوري الاكسرسايز 5 و 10 هنا عم يحكوا عن سبرينج. انا عم شوف انا الريكوردينجز
You have
ما كانوا عم
everything.
يفسروا.
You have
انا سمعت
everything. You have everything in this chapter.
اوكي حتى السبرينج لانك عم شوف فيديوهات ما كان في تفسير على
يا دكتور ولا مرة حكينا عن السبرينج
بس ما السبرينج بتعرفوه من السكول. It's K delta L. You don't know how to
بلا
calculate.
بلا بس فكرت انه اذا مش هالشرحتيهم
No,
معه
this
اوكي
is the
خلص
only
دي
thing you need, the formula K delta L. And
اوكي دي
so you need to do them. بلا.
اوكي دي
Okay. Remember, you don't have
ودكتور
space mechanics. يعني بالslides you stop until بالend of cylindrical coordinates. You don't have
ايه
space.
على السلايد 49 يمكن شيء هيك.
Yes, you stop there. Yes. أصلا هون ما
والفحص
في
دكتور
problems on space mechanics.
يس الدكتور عرفت متى الفحص ولا لا؟
It depends on the situation. Okay. If hopefully we'll go back to campus next week, then we can decide on a new date. Okay. بس
دكتور
أكيد this Saturday.
بعتوا ايميل هلا من سكول اوف انجينيرينج انه يمكن next week رح تكون اونلاين، انه starting next week
طب خلص لكن يعني we cannot talk about the exam before getting back to campus. Okay.
Okay.
So please, in case ما رجعنا على اليوني, we need to proceed. يعني we need to start with chapter 40. So I will assign for
Okay.
you videos to watch, and as usual, I tackle your questions. Okay?
Okay.
Okay, deep. Thank you, doctor.
Welcome, guys.
Thank you.
Welcome. Bye.
Bye.